Today's video lesson will be areas of regular polygons. At the end of the lesson, you should be able to find the area of a regular polygon. Remember that a regular polygon has all equal angles and all equal sides. So a regular polygon has a center, has a radius, and has an apothem. You have to know that the radius of a regular polygon goes from the center of the polygon to the vertex of a polygon, and the apothem goes from the center of the polygon to the side perpendicular. So out of these two segments and the blue line and the radius, okay, the radius will bisect this angle. So the radius goes from the center to the vertex of the polygon, and it will bisect that angle. The apothem goes from the center perpendicular to the side, and it bisects the side, so the side gets bisected. The apothem will also bisect this angle up top. So parts that you need to know: a radius of a regular polygon, center to the vertex. What does the radius do? It bisects that angle. And the apothem, you have to know what an apothem is. It's a segment that goes from the center of the polygon to the side of a polygon, and it's perpendicular and bisects the side. You have a central angle that's formed by two radii in a regular polygon, and the central angle is equal to 360 divided by n, where n is equal to the number of sides in the polygon. So in this example, angle 1 is my central angle. The half central angle is formed by a radius in the apothem. Well, my apothem is from, I'll label this B to D. So the apothem is BD. The radius is BQ. So half central angle, I'll label this 2, is right there. So angle 2 is the half central angle, HCA. And then I have the base angle, which is formed by a radius and a side. Okay, this is going to be angle 3 is my base angle. Base angle is angle 3 down here. So I have my central angle, I have my half central angle, and I have my base angle. Your base angle is equal to 180 minus your central angle divided by 2, or 90 minus half your central angle. Your half central angle is 360 divided by 2n. So your half central angle is 360 divided by 2n, where n is the number of sides. Okay, all these angles are going to come into play when we start finding the area of a regular polygon. So since this is regular, I know that all these sides are congruent. Okay, and all the angles are congruent. So you have to know these angle measurements. You have to know how to find the central angle, which is formed by two radii, which is equal to 360 divided by n, where n is number of sides. You have to find the half central angle, which is formed by a radius and an apothem, which is angle 2, and that's 360 divided by 2n. And you have to find the base angle, which is formed by a radius and a side, which can be found by 180 minus your central angle divided by 2. So let's put this into play. Figure is a regular pentagon, so it has 5 sides, with a radii and an apothem drawn. What's the measure of each numbered angle? Well, angle 1 is my central angle. The central angle is 360 divided by n. Well, the number of sides I have is 360 divided by 5. So 360 divided by 5 gives me 72. So my central angle is 72 degrees. So that's angle 1. Angle 2 is my half central angle. So angle 2 is my half central angle, which is 72 divided by 2 because it's half my central angle. So take half of 72 and you get 36 degrees. And then angle 3 right here, angle 3 is my base angle, and that's going to be equal to 180 minus my central angle divided by 2. Well, how did I know that? It's right here. 180 minus central angle divided by 2. So it's 180 minus my central angle, which is 72. Take all that and divide by 2. So I take 180 minus 72, what's 108. So 108 divided by 2 is 54. So my base angle is equal to 54 degrees. So you have your central angle, 360 divided by n, your half central angle, which is 360 divided by 2n, and then your base angle, 180 minus your central angle all over 2. Central angle formed by 2 radii, half central angle formed by a apothem and a radius, base angle formed by a radius and a side. So let's apply this to a regular octagon. Octagon has 8 sides. So angle 1, I have to identify that angle 1 is my central angle because it's between 2 radii. So that's my central angle. So that's 360 divided by 8. So 360 divided by 8 gives me 45. So my central angle is 45. Angle 2 is my half central angle. So that's 45 over 2. So that's 22.5. So my half central angle is 22.5 degrees. And angle 3 is my base angle. So that is going to be 180 minus my central angle all over 2. So 180 minus 45 all over 2. So 180 minus 45 is 135. 135 divided by 2 is 67.5 degrees. Now in the next couple slides you're going to find out why we need to find these 3 angles. The reason why we need to know those 3 angles is because if we want to find the area of a regular polygon, we're going to need to know certain angle measurements of that polygon. So the basic formula for area of a polygon, a regular polygon I should say, is area is equal to half times the apothem times the perimeter, where perimeter is equal to n times your side length. Basically when you do this you're actually finding the area of one triangle and multiplying it by how many triangles are in the regular polygon. So half times the apothem times the perimeter equals area of any regular polygon. So if you're given a side length in the apothem, remember the apothem is from the center of the regular polygon to the side and perpendicular, your area is half times the apothem times number of sides times your side length. And we're going to get into some examples. Okay, so let's do that first example right now. So we'll go with a nonagon. So I have 9 sides. This is a regular nonagon. So this is a regular nonagon. And I want the area. So if I want the area, here's the center. That's perpendicular. And I'll say this is 5, and this is the apothem. We'll go with 8. So if I want my area is equal to half times the apothem. The apothem is 8 because it goes from the center of the circle to a side perpendicular. Number of sides, nonagon, is 9 times my side length, 5. So it's a half times 8 times 9 times 5, which is 180. So my area of this example is 180 units squared. Going back to the previous slide, you also have what happens if you want to find the area and you're only given the radius. So if it's a regular polygon and you're given a radius, you can find the area by doing half times n times r squared times sine of your central angle. So remember that CA is your central angle, which is equal to 360 divided by n. So let's use this case, and again, this is for regular polygons only, given a radius. So let's do an example. We'll do a septagon, 7gon. So I have 7 sides, so this is a regular 7gon. So all sides are equal, all angles are equal, and I'm only going to give you a radius. And a radius goes from the center to the vertex of an angle that is created by 2 sides. So here's my center. I'm going to give you a radius of 4, and that's it. And it's a regular 7gon. Well, the first step, if this is the case, I need to find my central angle, because the central angles were used in this area formula. Well, the central angle is 360 divided by n, which is 360 divided by 7. So 360 divided by 7 is 51.4286, so we'll round it to 51.4. So your central angle is 51.4 degrees. Step 2, I'm now going to input everything into my area formula. So area equals half times number of sides, 7, times my radius squared, 4 squared, times sine of my central angle, which is 51.4. Make sure your calculator is in degree mode. So enter everything to your calculator and round to the nearest tenth. So a half times 7 times 4 squared times the sine of 51.4. So area of this regular 7gon will be equal to 43.8 units squared. So there's a lot of formulas to remember with area of a regular polygon. So you have half times the apothem times the perimeter. That's if you're given a side length in the apothem. If you're only given a radius and it's a regular polygon, area is half times number of sides times radius squared times sine of your central angle. We're not done, because you can find the area if you're only given the apothem. You can also find the side length. So if you're given the apothem and you want the side length is equal to 2 times the apothem times the tangent of half your central angle. If you want the area and you're given the apothem, your area is equal to tangent of the half central angle times number of sides times the apothem squared. So let's do an example. I'm going to say this is a this is a regular hexagon, so this is a regular sixagon. I'm going to give you the apothem and I'll say it's 5. So we'll do the first formula. So given that the apothem is equal to 5, your side length is equal to 2 times 5 times the tangent of my half central angle. Remember that your half central angle from the previous slides is equal to 360 divided by 2n, which is 360 over 2 times 6, because the number of sides is 6, which equals to 360 over 12. So 360 over 12 is 30. So my half central angle is equal to 30. So my side length is 2 times 5 times tan of 30. So 2 times 5 times tan of 30. So this will give me 5.8. So my side length is 5.8 units. So if my apothem is 5, my side length is about 5.8. So let's use the same example. So given my apothem is equal to 5, let's find the area. The area will equal tangent half central angle, which is 30, times number of sides, which is 6, times the apothem squared, so 5 squared. So area equals, so we have tangent of 30 times 6 times 5 squared. So area, enter that onto your calculator, is 86.6 units squared. So there's your 2 examples. Okay. Given the apothem of a regular polygon, you should be able to find the side length. And given the apothem, you should also find the area. Okay, there's 2 more formulas that you have to remember here now. Is if you're given the side length and you want the apothem is going to equal the side length divided by 2 times the tangent of the half central angle. Okay, let's do this first example. Okay. We will keep up with we'll just use the hexagon still. That's fine. So given the side length, so I'll give you a side length of, let's go with 10. Okay, so we'll do equation 1. So your side length is equal to 10. So if the side length is equal to 10, the apothem will equal to your side length, 10, divided by 2 tan half central angle. Well, we found our half central angle from the previous example. The half central angle again is 360 divided by 2n. So 360 divided by 2 times 6, which is 30. So tan of 30. So the apothem, when you do 10 divided by 2 tan of 30, you get 8.7. And that should, 8.7. So we were given the side length of 10. We wanted the apothem. The apothem is, so I'll draw it in here for you, the apothem is the segment that goes from the center to the opposite side, or to a side that's perpendicular. Okay, so if the side length was 10, the apothem will be about 8.7. So let's do an equation. Given side length 10, what's my area? So if you're still given your side length of 10 and you want the area, it's going to be number of sides 6 times my side length squared, so 10 squared, side length squared, over 4 tan 30. Again, HCA is half central angle. Enter that into your calculator. So I have 6 times 10 squared over 4 tan 30. So the area will be about 259.8. 259.8 units squared. So there you go. Given side length, you should be able to find the apothem. Given side length, you should be able to also find the area. Let's do more examples. What's the area of the regular decagon at the right? Well, I want area, so I'm given the apothem and a side length. So therefore my area is equal to half the apothem times the number of sides times my side length. So area equals half the apothem, which is 12.3. Number of sides, decagon, is 10. Side length is 8. So my area is half times 12.3 times 10 times 8. 492 inches squared. What's the area of a regular pentagon with a 8 centimeter apothem and 11.6 sides? So same thing. Given the apothem and the side length, therefore area equals half the apothem times number of sides times your side length. Remember, number of n times SL is your perimeter. So area equals half, my apothem is 8 times my number of sides in a pentagon is 5 times my side length is 11.6. So half times 8 times 5 times 11.6 gives me 232. So my area is 232 centimeters squared. So a honeycomb is a hexagon. The length of a side is 3 millimeters. What's the area? Okay, this one's okay. Given a side length of 3 millimeters, and I want the area. Well, let's go back to our formulas. Given a side length, I want area, so this is my formula that I'm going to use. Here we go. So I want my area. Well, I need my half central angle, HCA, which is 360 divided by 2n, which is 360. Okay, hexagon is 6. I already know this. 2 times 6, which is 360 over 12, which equals 30. So my HCA is equal to 30. Number of sides, 6. Side length gives me is 3. So let's plug it in. I have 6 times 3 squared over 4 tan 30. So I have 6 times 3 squared over 4 tan 30. 23.4. So my area is about 23.4 millimeters squared. So I give you a side of a hexagon, which is 16 feet. What's the area? Well, I have a side length of 16. Okay, this is what's given. I want the area. Well, given side length, I want area. It's the same formula. So here's the formula. So side length is 16. Hexagon. Okay, hexagon is 6. Half central angle of a hexagon is 30. We found that throughout the lesson today. So plug in numbers. 6 times 16 squared over 4 tangent 30. So that's my area. So I have 6 times 16 squared over 4 tan 30. So my area is about 665.1. So 665.1 feet squared. And that concludes our area of a regular polygon lesson. Please do the practice problems and write down all the formulas that we covered and ask any questions, please.